R versus Python, Python versus R. These two languages are, although they're excellent tools in their own right, very often conceived as being rivals. Data science is a field divided. You've got a Python camp and you've got an R camp. And the members of those two groups each fervently believe that their chosen tool is superior. Now, I believe that the divergence doesn't lie with the tools. It lies with the people. You've got the Python users, and you've got the R users. And what is the intersection between those two groups? Well, it's very, very small. There are not an awful lot of people who are using both Python and R. And within that intersection, there are an even smaller group who are using Python and R together on the same project. Now, I have it on good authority that amongst the most committed R users, there are some who from time to time really, really wish that they had access to the object-oriented capacities that are native to Python. And similarly, amongst the most rabid Python users, there are some who yearn for the wide range of statistical distributions that are available within R. So to pitch these two languages as being mutually exclusive is forming a false dichotomy. There's no inherent reason why there should be adversaries. Really, what we should have is them working together, again, side by side, hand in hand, on the same project, just to enable you to do better analytics. And if you're thinking about Paul McCartney and Stevie Wonder right now, that's no coincidence. So I'm Andrew Collier, and I'm going to be talking about mixed language programming with Python and R. As you can see and maybe hear, I come from South Africa. I'm a freelance data scientist with TopTel, and TopTel is a exclusive network of technical specialists, and many leading companies around the world use freelancers from TopTel to execute their most critical tasks. So these are some of the tools and technologies that I'll be talking about. If you're active on Twitter, please feel free to use these liberally, and I am DataWookie. So let's talk about these two tools in a very sort of high-level sense. According to a survey posted by RedMonk in the first quarter of this year, both Python and R are very, very highly rated on both Stack Overflow in terms of questions posted and answered, as well as on GitHub in terms of overall number of commits. So these, objectively, there's very little to choose between the two of them. And if you look at these rankings over time, then you can see that Python has been consistently highly rated overall as a development language. This is data science aside for a number of years, and R, currently sitting in 13th position, has been gradually gaining traction over the years. Let's take a look at the features of R. It is literally the grand dame of data science. Since its inception in 1995, it's captured a significant proportion of the data science industry, although it's more dominant in academia than in commerce. In the process, it's built up an enormous volume of packages. So CRAN currently has an excess of 10,000 packages. There are also a very large number of built-in data sets, which means that for newcomers to R, it's very easy to get started because the data is already there. There's a wide range of numerical and statistical capabilities within the language, and the documentation, as I'm going to show you a little bit later, is really quite superb. Although it can be a little bit opaque at times, it's difficult to get into it, especially when you're starting out. R really excels for standalone analyses, and it has two principal drawbacks to my mind, and that is that sometimes it can be a complete memory hog, and once your RAM is exhausted, your machine starts to swap out, and then everything grinds to a halt. The learning curve is also pretty steep, but once you get over that initial hump and you realize that it's pretty cool, it's plain sailing. What about Python? Well, Python is a bit of a debutante on the data science scene. I mean, the language itself has been around since the early 1990s, but in terms of data science applications, it's only a relative newcomer with the advent of libraries like Pandas and scikit-learn. It's an explicitly object-oriented language in opposition to R, and this means that it's very easy to write nice, well-structured code. And Python really excels for integration with other systems. And this is maybe one of the weak sides of R. As I mentioned, it doesn't have any native data science capabilities, so you have to include these additional modules to get started with data science in Python. And there are these issues with module dependencies that you have to resolve very often by using virtual environments. We'll take a look at that too. So my question is, how can we leverage the best capabilities of both languages? And the idea here is to mix the two of them together. So to look at a blend of Python and R. And this idea is by no means new. In fact, I think that most of us wouldn't think twice about embedding a chunk of SQL into either an R or a Python script. Right? So why would we hesitate about mixing up Python and R? It's exactly the same principle. So there are a couple of ways that one could go about doing this. So the one approach is you spin up an R interpreter and then you somehow incorporate Python into that. Or you take the other approach, and that is you run Python and somehow consume an R script. Or alternatively, you could, in principle, have both R and Python running in parallel in yet some other environment. That's not an option that we're going to explore this afternoon. So let's start off by looking at the possibility of using R within a Python environment. And there are actually a number of existing approaches to this problem. So there are at least 3 modules that will allow you to do this. And we're going to focus our attention on the third one, and that's RPy2, since this is the one that's been most aggressively developed at present. You can install RPy2 very easily with pip, and there's also a nice Docker image, which means that you can play around with this technology without making any major commitments. Right, let's see how this works in practice. So I'm going to be running all of this in a Jupyter notebook, and what I'm going to do is start off by just loading up a couple of libraries. But before I do that, I'm going to turn off warnings, because once you start running R inside Python, you discover that it produces a lot of warnings, the majority of which are pretty uninformative, so we're going to turn those off. We'll load up NumPy, Pandas, and scikit-learn, and then also another component of R2Py, which is going to allow us to easily move data back and forth between R and Pandas data frames. And then before we get started with the actual analysis, I'm going to create a couple of data sets, both of them randomized, so some uniformly distributed ages between 0 and 18, and then some heights that are related to those ages, so 2 arrays, and then package those arrays together in a data frame that ends up looking something like that. So an age column and a height column. And ultimately what I'm going to be doing is making a couple of plots with this in R and also fitting a linear model. Right, so let's get started with running R in Jupyter. In order to do this, we're going to use the Jupyter integration. There's also a high-level and a low-level interface that allow you to interact with R. But we're going to use the Jupyter integration because I think that's probably what the majority of people are using for their data science projects. In order to make that available, you have to load up this extension, and then you have 2 magic commands available to you. So the cell level magic, which is the double %R, and then the line level magic with single %R. If we just take a look at how those work in practice, if we want to evaluate a chunk of R code with the inline magic, then we simply specify the R code and we precede it with the magic. And when we execute that, we get back the corresponding piece of data from R. And here, maybe just a couple of explanations. One is that if you're a Python developer, you might expect these periods to have some significance. They don't. In R, a period can simply be a component of a variable name. And this dollar is actually more like the dot operator in R. So what we're doing here is looking at this variable called r.version, and we're extracting from it the component called version.string. Okay, let's do something else then. We're going to generate a vector of normally distributed random numbers, assign them to a variable called heights in R, and then return the results to Python as a NumPy array. So that's very, very nice. The translation from R to Python is pretty seamless. I guess the majority of us are more interested in looking at tabular data in R and Python, and that integration works very smoothly as well. As I mentioned before, R has a number of built-in data sets, and one of them is called empty cars, some characteristics of some really old vehicles. So what we can do is, looking at the first 6 records of that in R, we can pull it straight through into Python, and it arrives as a pandas data frame. And of course, you can then go and consume that as part of your analysis then within Python. We can also make assignments directly from these magic variables. So, for example, we can assign the output from the inline magic to a variable, and this means that that will then become available in our Python environment. If I can type in the cell. All right. Sorry. Yep. There we go. Okay, so there's the data frame. This has been pulled directly through from R. And then this is what the cell level magic looks like, right? You execute R function, an R chunk of R code, and the entire block gets evaluated. Nothing actually gets returned. We'll see how we pass information back and forth from the cell level magic right now. Yes?
How about R-specific data structures like a factor?
Yes, it can. So the translation is not particularly neat. You have to run another function, which I'm going to show you presently, to actually translate that neatly into pandas. Okay, so let's look at a couple of applications. The first of them is going to be generating a regression model. And what I'm going to do is, using the -i argument to the magic, I'm going to pass in these 2 variables, age and height. And then within R, I'm going to use the lm function to form a linear model between those 2. So we read this first argument as, give me a model for height. The tilde is read as a function of age. Assign the results to a variable called fit. And then use the coef function to extract the coefficients from that model, assign them to another variable in R, and then use the -o for output argument from the magic to pass the data then back to Python. And one thing that's worth mentioning here is the assignment operator in R. If you're writing truly idiomatic R, then you use this assignment operator rather than a single equal sign, although a single equal sign will work just as well. So if we evaluate that, you'll note that the actual block doesn't return anything. But now if we take a look at the coefficients, we see, we've got back the coefficients very close to the ones that we actually used when we built the data. But if we take a look at that, we actually see that these coefficients are currently not actually a sort of a native Python data structure. We actually have to make this conversion, and this is the function that I was referring to. If you use that, then it will actually go and make the appropriate conversions for you from R to Python. And we can then take a look at a summary of the model. And this, I think, is one of the arguments in favor of doing this kind of modeling in R rather than Python, and that is that you don't get these kind of nice diagnostics in scikit-learn. Here we can have the p-values associated with each of the coefficients. That's pretty difficult to get out of scikit-learn. Okay, so let's take a look at another application, and that is plotting. What about generating a plot with just base R? So here, something super simple, just plotting a series of integers, firstly specifying that we want to just inflate the text size ever so slightly so that the folk at the back can see, and then plotting those integers, choosing red for the point color and opaque disks for the actual plotting symbols. And there we have a very nice but not particularly fancy plot. What about something a little bit more interesting? R has built-in diagnostics associated with the majority of its models, and we can actually go and plot out a couple of diagnostic curves associated with that linear regression model that we built a moment ago. So that's what we see there. So these are things that will allow us to diagnose just exactly how well this regression works. So one of the questions that you have to ask when you're doing a regression model is, does my data satisfy the requirements or the assumptions behind this model? And these 2 plots allow us to assess that. So, for example, on the left-hand side, we have a plot of residuals versus the fitted values, and we are hoping there not to have some sort of a systematic effect where the residuals are getting larger or smaller as the fitted values change. And similarly, on the right-hand side here, we have a quantile plot, which allows us to assess whether those residuals are normally distributed or not. Final example of plotting is using the ggplot2 add-on package in R. So this is a very commonly used package if you're wanting to make sort of presentation quality plots in R, and it's built on this idea of the grammar of graphics, where you essentially build up a plot by superimposing a whole series of layers until you have your final product. So we start off with the growing data frame that we're passing in as our input argument to the magic, and choosing the age and the height as the x and y values, putting on some scatter points, and then a smoother, which is just going to superimpose the linear fit with some confidence intervals, and we end up with a rather nice, well, I guess pretty close to publication quality plot. Okay, so final illustration of the use of R within Python is generating some synthetic data. This is something that I have to do fairly routinely because I have models that I'm building. I don't have any real data to train them on, so I want to build some synthetic data for them. And I have no doubt that there are good libraries in Python for doing that, but in R, there's a great library called Charlatan, and it does this job magnificently well. So I'm going to load up the library Charlatan, and I'm going to generate some synthetic people, and I'm going to do this just because I can, in a French locale. So I'm going to be generating some French names, some phone numbers, and job descriptions. So let's go ahead and do that. And I think those will look pretty French to me. And we can add some stuff to that as well. So supposing we want to put in a company name as well, we can have synthetic people, company, and we can use this company function to generate another one of those 10. And of course, we want that to be in the same locale. Right, we can add those in and take a look at what the synthetic people look like back in Python. And as you can see, it kind of almost looks like a pandas data frame, but not quite. And that's because the translation doesn't happen automatically with this cell level magic. But we can easily do that by using that translation function, and there you end up with a very, very nice, valid pandas data frame, which you can then incorporate into the rest of your analysis. Okay, as I mentioned before, there's also a low level and a slightly higher level interface, and these allow you to basically twiddle with things if the Jupyter integration doesn't work particularly well for your particular problem. Okay, so let's go back to the presentation and think about doing things the other way around, and that is incorporating Python into your R workflow, presuming that you have an R workflow. And again, there are a number of packages that allow you to do this, and we're going to be talking principally about the final one called reticulate. And this is a library that's been very aggressively developed by RStudio, which is the IDE, one of the IDEs for R. And reticulate is available on CRAN, so there's a nice stable version, but if you want to live closer to the bleeding edge, you can also install it directly from GitHub. So let's take a look at how that works. So the first thing we do is we load up the reticulate package, obviously, and there we go. And then we're going to load up two more packages, one called magic, and this is going to just allow us to produce some magic squares. Again, I'm sure it's possible to do this in Python, but there's a magic package in R, which I'm going to use just for generating some test data. And I'm also going to use Magrita, which is a fairly recent package in R, but it's become very pervasive because it provides this pipe. And having the pipe in R allows you to write some of the most elegant code you can imagine. Okay, so I guess one of the first things we should do is check whether there's a Python executable on my machine. And I guess, yes, there is. There we go. It happens to be the Python 2 executable, which is a little bit disappointing. But if I run pyconfig, then I see that the reticulate package actually, although it picks up this as the default interpreter, that's because it's the first match on my path. It also recognizes that there are a couple of other interpreters available, so there's also a Python 3 in the same folder, and there's a Python interpreter in a virtual environment sitting in my home folder. Okay, we can actually choose to use one of those alternative interpreters by using the use Python function. The only caveat to that is that it has to be the first function that you run after you load the package. As soon as you start interacting with Python, as we're going to see in a moment, it actually binds to a particular version of the interpreter, and once that's happened, it's hard to go back. Okay, so I suppose that one of the principal reasons that one would want to explore this integration is to take advantage of all of Python's cool packages. And the way that this works in reticulate is very nice. You run the import function, and it effectively takes the entire package and assigns it to a variable in R. So, for example, if you wanted to access what you would normally do with sys.version in Python, you would do sys$version in R. So that's very transparent. It works for attributes within modules, but it also works just as well for functions in those modules as well. So, for example, if we load up the OS module, we then have access to all of its capabilities, and we can see, for example, we can get the current working directory and compare it to the corresponding thing generated directly within R. We can also list the files in that current directory and do the same thing in R. So as you would expect, the results are exactly the same. But the reason that I mentioned these functions is because my next thing is to look at the associated documentation. And as I mentioned before, the documentation in R is really, really good. So just looking at this essentially quite simple file, function at least, we see that the documentation for list files is really very extensive. There's a lot there. And what I think is one of the nicest aspects about R's documentation is at the end of each of these pages, there's an example section. That's generally where I start when I'm trying to understand a new function, see a couple of use cases, and then once I've kind of got my head around how to use the function, I'll then go back and try and digest all of this other information. We can also access the associated Python documentation directly from within R now as well. But as I think you will agree, relative to the R documentation for the corresponding function, this is somewhat terse. Right, so as I said before, you sometimes have these dependency issues between modules and Python, and you get around this by having virtual environments, and you can actually set up these virtual environments and interact with them very nicely from within R as well. So let's take a look at where these virtual environments live on my machine, and they're in this hidden folder in my home directory, so virtual environments, and I can list the ones that I have available. There's just this single one called test, which I created for this demonstration. If the environment is not existing already, we can create one from within R as well by running this virtual environment create command. Of course, that's not going to do anything right now because the environment already exists. We can check on what the configuration of that environment is, and we can see that by default, it's hooked up with the Python 2 interpreter, which is probably not ideal. And currently, the developers for Reticulate are working on a more robust way for you to actually select the interpreter that you're going to associate with a particular new virtual environment. And the objective with this, of course, is to start installing modules, and we can do this as well from within R by just specifying a vector of module names, and Reticulate will then go and run pip for each of those and execute the install process. And right now, all I want to do is hook up with this virtual environment and start doing things. So I say, right, use that virtual environment and start importing libraries, and the first thing I get is an error. That's kind of disappointing, isn't it? But there's a good reason for this, and it's what I said before about Reticulate binding to a particular environment. Right? It's now hooked up to Python 2. If I want to change to the Python interpreter in a different virtual environment, I need to actually detach myself from Reticulate and then reattach so that I can hook up with a different interpreter. So I detach and then reattach, and I'm now really working in that virtual environment. I can go and check that all of those modules that I installed are now available, and I can load them up. So let's start actually doing things in Python, and I'm going to generate some data in R using that magic function. So this is just going to be a 7x7 matrix. So these magic squares are just a little mathematical oddity where all the sums of the columns and the rows are all exactly the same. So we can validate that in R. All of these rows and columns all sum to 175, as does the principal diagonal. But now, if we're wanting to do manipulation on this matrix in Python, then we can access functions within NumPy directly. So, for example, if I want to use the transpose function in NumPy, it's just NumPy $transpose, and I provide the argument, my R matrix, and there I get the transpose. I can calculate the eigenvalues and the eigenvectors. Of course, I could have done all of this natively in R, but the idea here is to illustrate just how easy it is to shift data, like compound data structures, across to Python. Now, I hope that you're concerned, I was concerned, about taking an enormous matrix and literally copying that across to Python and then shipping the results back. That sounds like an awful lot of information moving around. But in fact, it's super efficient because your R process and your Python process are actually memory mapped together. So they are looking at precisely the same data structures. There's no copying back and forth taking place, which makes the entire process super efficient. Okay, what about actually executing some code? Well, this is very straightforward. We can run string. That will execute the string in the Python interpreter. We can also run an entire file using run file. And whatever variable we've then created, for example, in Python, I've just created a variable called x and given it a value of 10. I can then access within R using this special object called py. So $, will give me access to that. I can assign to that directly from within R. So this is not a read-only relationship. Here it's worthwhile pointing out that numerics in R are floating point by default, so you might expect that to be a 13 integer in Python. It's not, because it's going to be already floating point in R. And we can create new variables using this same process as well. So this is a very transparent way of interacting with variables present in your Python interpreter. But probably what's of even greater utility is this source Python function. And this actually allows you to source an entire Python file, and all of the objects that are created then become first-class variables within R. So let's just take a look at what that file has in it. I'm creating a simple class called person, and then a couple of objects called Emma and Storm. And if I source that, and then go and take a look at Emma and Storm, notice there's no $, prefix on these. These are actually first-class variables in R. Then I see the contents of those two objects. And a very, very cool thing, if you're an R user, is the fact that I can now actually instantiate these classes directly in R. Right? So I defined a class in Python, but I can now actually generate instances of it directly in R. So I'm creating a Claire and I'm creating an Elizabeth by just passing through the arguments to their constructors. And I can access their attributes, right? The ID, the name, and the birth date. I can also run methods on those objects. It's all very straightforward and pretty much what you'd expect to be, but I still feel that it's a whole lot of magic. This kind of capability is huge if you're an R developer. You can also launch the REPL from within R, and this means that you can actually start running interactive code. So note here that this is not R anymore. I'm actually interacting directly with the Python interpreter here, and I'm typing in live code, and it's been evaluated live. A great thing here, though, is the fact that once I'm in the Python REPL, I'm able to access variables from R as well. So, for example, there's an iris data frame in R. I can now access that from within Python by using the R special object. So r.iris now gives me access to the iris data from R. So this viewing happens from both sides. Like the Python interpreter can see R through the pipe, and the R interpreter can see Python through the pipe, which is exceedingly cool. And the other thing is that this data structure that we're viewing from Python is actually going to be interpreted as a data frame. So there we go. We can run head on it and get the first 5 records. So from the Python perspective, this is a pandas data frame. Okay, so the chairman has just indicated me that it's time to wrap this up, so I will do that. I hope that I've impressed upon you that integrating R in Python is a cool thing to do, but it also expands the range of possibilities. Using RPy2 and reticulate, it's actually pretty straightforward to do this. As an R developer, my preference would definitely be to go the reticulate route. I also just think that the integration there is a little bit better. But of course, depending on your choice of language, your opinion may vary. Okay, I think that both these languages are really important and that any data scientist should be at least conversant in both of them. And I think this is a very nice way of accessing both languages. Does this need to be an exclusive relationship? Hell no. We can divide our allegiances between them. There's no reason why you shouldn't serve two masters or have two lovers. And this now enables you to get the best of both worlds. If there are any questions, I'd be happy to answer them quickly.
Hi.
Hi.
Thanks for the talk. I'm using both, but not together so far. So this will be my next challenge. Do I understand you correctly that if I'm using R out of Python, that the memory is not shared, and if I then swap big amount of data, then this can be a mess?
Yes, so that is my understanding of what happens in RPy2, is that you don't have this, it's not memory mapped. I stand to be corrected on that point, but that's my understanding, yes. Whereas if you take the reticulate route, then there's no overhead associated with moving data back and forth.
Thanks.
I think that's a very strong argument to run reticulate.